What I'd like to do is basically we have Josh Wolfe, who you know is a longtime friend of the of Strategic News Service, hosted a panel last year on nanotechnology. Josh is the co-founder of Lux Capital and the publisher of the Forbes Wolfe Nano Report, and is probably one of the most knowledgeable venture capitalists in the nanotechnology community. And Josh is going to give us a nice overview of what's happening. I think we're seeing a convergence today, nanotechnology across a number of sectors. In energy, he's clearly, I think, at the forefront today. And there's a lot of activity in the venture community in nanotechnology. So we're going to talk about that with Josh. We have Vieau from A123 Systems, one of the leading nano-enabled battery technology companies in the world. Dave's been a very, very busy man. He's going to be going up to LA, talk with the governor and Jeff Immelt at General Electric later today. He's going to have some very interesting things to say, I think, about how nanotechnology is impacting battery technology. And then, of course, we have our friend Keith Blakely, who was here in 2004. Keith is the chairman, CEO of Nanodynamics out of Buffalo. And they are leading the way in many interesting areas in the energy, water technology. And so we're going to basically have, I think, very lively discussion today. And I want to get into it, Josh. You, one of your portfolio companies, Lux Research, just released, 2 weeks ago? A report on clean technology. And this is sort of an evolutionary thing for you guys. You've talked a lot about nanotechnology and energy, but your partners have created a platform to really formally introduce this into the marketplace and address some of these key issues. So in terms of, maybe you can give us just an overview of what's happening in the nanotech, clean tech space and where you kind of see things evolving.
Sure. So first of all, I don't know if Mark knew sort of the intricate backgrounds, but the first panel was a perfect sort of serve up. I think either a year ago or 2 years ago, we had Mike Knapp, who was the CEO of one of our companies, Cambrios, who was actually commercializing the work of Angela Belcher, who was a grad student of Dan Morse from UC Santa Barbara, who had sort of reverse engineered the abalone and thought, can we use biology to find gene sequences that have proteins that have binding affinities towards inorganic materials and actually grow electronics rather than do top-down lithography. So that's sort of one of the camps of nanotech and material sciences. Can you do bottoms-up assembly? And then Angie is doing collaboration with Yet-Ming Chang, who's one of the scientific founders of A123, to do sort of virus or biologically mediated assembly of batteries. And so I think it's sort of an interesting background. We always say that we sort of shave every morning with Occam's razor, and we try to keep it as simple as possible. We came up with this term complexity, and the idea being that you take complexity out of big manufacturing processes, things that are primarily dominated by, say, vacuum processes, and switch it into wet chemistry. So go away from lots of capital equipment into something that's more solution-based, because that's in a sense the way that nature has done it. So that's one of the guiding principles, and I think that's something that in our own investment philosophy in nanotech and clean tech and in energy, it's sort of the driving, umbrella, overarching thing. I would categorize maybe 3 or 4 things that we're looking at. I think these guys represent very well. One is new materials discovery. So we made a recent investment in a company called Accelergy with Goldman Sachs and Sequoia Capital. It was announced maybe 2-3 months ago. And these guys are doing high throughput analysis and discovery of new materials for converting coal to liquids, discovering new battery materials and electrode materials. And that's something that if you take the principles of what has gone on in the big pharma for 10 years and you apply that kind of high throughput chemistry and combinatorial analysis to materials discovery, I think you increase the odds of having sort of a low probability, high magnitude impact. And that's sort of the nature of our business. The second area is broad electrification. So, if you look at every device that we have, at some point it was sort of mechanical in nature, and it has become solid state. If you think about lighting, going from incandescent to now compact fluorescent to LEDs, that's a big area of interest for us in terms of efficiency, power, and of course in simplicity of design. But probably the most important, I think Dave is going to address this far better than I, is the electrification of automobiles. There's without a doubt in my mind that this is the trend more so than, say, some of the biofuel and gasoline substitutes. That the future, whether it's 10 years, 5 years, 15 years, is almost definitively going to be a automobile that looks like a 2-ton Cuisinart that is essentially getting power from the grid. And then the question is, well, where do you get that power from? And if you had to poke me further on that, I would say that the one sort of underlooked area is nuclear. And this is sort of a solicitation to the crowd. I'm on a foraging experiment now, talking to all universities and government labs that are doing novel material science in both fuel cycle of nuclear as well as containment and waste remediation. I think it's absolutely sort of the push. And then the sort of other big macro thing that we think about in terms of nanotech is if you think about energy density, you've essentially gone from a carbohydrate economy to a hydrocarbon economy to uranium and nuclear. We consume, I think, something like on the order of magnitude of 100 quads BTU a year in this country, and one quad's about the size of a enormous forest. Coal has about 2 times the heat density and power that can be produced by burning it in a turbine. Natural gas and oil about 2 times that, and nuclear about the equivalent of 4 tons of coal. So again, the transition going back towards a agrarian or carbohydrate economy to me is something that's doesn't make a lot of sense. So very interested in nuclear and electrification and in new materials chemistry that can be used in batteries. So maybe I'll serve that up to you. Yet-Ming Chang is a scientific founder of A123 out of MIT, an absolute brilliant guy, very commercially minded.
Josh, you guys have mentioned the word bubble in conjunction with what's going on right now in the marketplace. When you look at what's going on in China, what's going on in the emerging markets overall, the tremendous demand for clean technologies. I mean, really, the only way we're going to bring these countries into the developed world is through these technologies, I believe. So the word bubble has been used a lot in the past decade. But when you look at what's going on right now in the venture capital community, I mean, are the valuations so stretched now that it's hard for you to look at a deal seriously and consider doing it? Or are you still seeing, reasonable valuations on deals where you're willing to take a look at it and get involved?
So, there's a dichotomy between private and public markets. One sort of lags the other in a sense, or sets the comps for the other. In the public markets, I think you're seeing, things like First Solar and Pacific Ethanol and others, and they have their own sort of valuation characteristics. We don't do anything in the public markets. And I think in the private markets, things are reasonable in terms of price, but, it's the nature of the venture business where you essentially are buying a lot of lottery tickets, all of us. And, it's very difficult to tell which ones are going to win, whether it's, in the case of solar, which I'm a huge proponent of, it's very difficult to know today if the new technology is going to be the defining characteristic, or if it's access to political money and non-dilutive financing or management that is able to strike a deal. And you get to a point when you have so many people in a field that it gets so saturated and fragmented that it's very difficult to pick a winner. So we sort of say, we applaud the endeavor, but we prefer to sit out the ride just because it's gotten too hard. So, I wouldn't characterize it as a bubble. A friend of mine has written in the past that in greed and avarice lies the hope of progress. And I think that's the nature of markets, and I think it's a beautiful thing. And you pointed about this sort of that there's a zeitgeist of pessimism in the country, and I'm with you 100%, man. I think the venture capital and greed and innovation is the basis for optimism. And so I think we're going to see wonderful things. I think a lot of people are going to lose a lot of money. A lot of people are going to get fantastically rich, and we're going to change the world in the process.
Right. So. Right. Well, that's I think that's a great overview, sort of what's going on. Let's drill down now with Dave. We're delighted. This is Dave's first time with us, CEO of A123 Systems. I think you'll be hearing a lot more about this company in the months ahead. Wired magazine, our friends at Wired last year wrote an article entitled "Building a Better Battery," and they asked a simple question: can anybody build a battery that doesn't stink? Which I think is a fair question, Dave. And so when Mark and I and the gang were discussing the panel, we looked out at the companies out there and said, well, here's a company that's building a battery that seems to not stink and actually is making traction and inroads in the marketplace today. You may not have heard yet of A123 Systems, but I think in the future you will. So we'd like to welcome you, Dave, to the panel. And what I'd like to do is just sort of have you give the audience a broad overview of your battery technology, what you guys are doing. We're going to have a breakout session this afternoon at 4 o'clock, so we'll be able to drill down even more. We'd love to have you participate in the breakout. Right now, Dave, I'd like you just to kind of give us a big overview of what you're doing at A123 and where things are going in the next year or two.
Sure. I'll try to get it down to a few minutes or so about the story. But A123 is about 5.5 years old. It was founded out of some guys out of MIT. And we licensed 2 bits of technology there. One of them was for a really radical design for a battery, concept of a self-organized battery that, based on nanoscale dimensionality and particle forces, would allow you to take ingredients, mix them together, and they would self-form into a battery. And the name of the company, A123, is derived from a Hamaker force constant related to these particle force measures. That one's still in the lab. The second one is technology that we had, which was a new battery ingredient, a cathode, a nanoscale cathode, a nanophosphate material that had been developed initially at MIT. And we commercialized that material in the early stage of the company and created some batteries with unique properties. And just one thing is that when somebody has a new battery, the first thing you got to ask for what? Because I don't know of any battery that does it for all, and they don't. They have specialty characteristics, and they fit certain requirements. And the properties of this battery that made it unique and different from other lithium-ion technology involved the ability to have much, much higher power capability. Power, I mean, think current amps. We could make a small cell that could deliver 200 amp pulses of current. And the standard laptop battery, that's not something that's very important. What's important in a laptop battery is packing as much energy as you can into a small space and sipping it out real slowly. And this technology really wasn't ideally suited for that. It has some merit there, but the primary benefit of the product was it could generate tremendous amount of power. And the second thing is it could give you much, much longer cycle life, charge and discharge, and also calendar life. Very stable chemistry. So any application that required lots of charges and discharges or long life, remote location and the like would be very appropriate. And third was a better safety, an improved intrinsic safety over the traditional lithium-ion batteries. And you probably have seen some problems in the industry as a result of chemical instabilities in batteries. Well, these batteries have a cathode, our batteries have a cathode which is much more stable. So we took all of that and made a decision to build some cells, but we wanted to have a lighthouse project that we could prove the merits of not only the performance but the economics of it. I think that's one of the challenges for all of us in these new technologies is we can make it work, but can we make it work where people will really buy them, and can you make a buck at it?
Yeah.
And it's challenging when you've got new chemistry, new product application, brand new customers. But we worked with Black & Decker DeWalt division. They make the world leader in cordless tools. And they basically said, if you can do what that PowerPoint says, we'll buy everything you can make.
Wow.
Yeah, right? So, well, we went, and we did do actually better than what the PowerPoint said, and they did buy everything we could make for a while. But what these tools did, and it was a good union between the technology and the application, which I think is a great model for which companies could follow if it's possible. They didn't just take the technology and stick it in an existing product. They designed a product around the technology. And it took a little longer to do that, but what they did is they created a higher voltage platform with capabilities and tools that had never been seen before. And you can deliver more power on a battery-operated tool today than you can get off of the line cord in a 115-volt socket. That's 2,400 watts of power, and what it means is you can operate full-size professional rip saws that can cut more efficiently, 20% better than the corded versions. So they really hit the cover off the ball on what they were trying to do, and it's been a great union between the two. And it was good for us because we had to scale our powder production, we had to scale our coating capability, we had to scale assembly, we had to demonstrate that we could meet the quality levels, and we had to show that the product was reliable. And having done that, we've created a kind of a baseline for the next applications, which are heading in the direction of transportation, the electrification of the automobile, and we've got early stage programs going on now with General Motors on the Saturn View plug-in hybrid, and some other automobile companies which are to be named later. And we're working on a hybrid bus application with GE on a fuel cell bus project, and we're working with BAE Systems on the Daimler Chrysler Orion bus system, which is used in some of the major cities. It's the #1 leading hybridization buses. And in the application for that, we're able to save on per bus 3,400 pounds of weight by implementing our batteries as opposed to the batteries that had been in place prior to this. So there's very significant weight savings. It implies a significant improvement in fuel economy. There's a significant benefit in life and also in overall cost as a result of it. So the company right now is using its technology in the place where it best fits. It isn't in cell phones, although there are some interesting applications there. And I will say there are going to be some consumer applications for the technology and some other areas that you'll see on the merits of very fast charge and good economy and safety and long life. So I think the nanotechnology is a stepping stone. What's here is to create new products. Those that you see today are the most obvious, and then the other ones will come later.
So that's wonderful. Are you finding, and Keith will talk a little bit more about this, but are you finding that the processes around nanotechnology are enabling you to do things that you could have only dreamed of like 10 years ago? I mean, is this really, I mean, I've always viewed nanotechnology as a general purpose technology, cuts across a lot of different platforms. But are you finding in the labs that you're able to do things? I mean, you said Black & Decker had to redesign their power tool. I mean, when you look at what's happening at the nanoscale, it seems like the sky's the limit almost as what you can do, you know, at least theoretically with these things, how powerful they can get. I mean, I'm just astounded at the power that you can get today with your battery versus, you know, a plug-in product.
Well, it is fundamentally driven by the nano characteristics of the core particles, and it allows you in the battery application to get a great degree of surface area, and the interactions that are going on are happening at a much faster rate. So we get much lower cell impedances, and we get much higher rate capability, meaning translating into higher current. But you also get much longer life. Batteries are systems that when you cycle them, they swell and they shrink, they swell and they shrink. That cycling characteristic has a mechanical kind of grinding characteristic to it, which ultimately degrades the performance. And anyone's ever had a battery, it starts out a certain level, and what it does over time is that performance fades. The ability to retard that fading by having a system that's very stable and built on nanoscale architecture is a critical component, because one of the elements, cost. For instance, if you want to put a battery in a vehicle and you want it to last 10 years, you have to size the battery for end of life. It means it has to have enough energy and power after 10 years to do all that it's supposed to do day one. If the battery has a characteristic like we see with our cell phones, where after 18 months you see a tremendous loss of energy, you have to oversize the battery, sometimes by 2 or 3 times. And if you do that and you create a battery too thin, the initial costs are too high to make economic sense. So having batteries that are very, very stable over time allow much lower costs, and it's all built around the fundamental ingredients. So it is a nanoscale fundamental thing. And we're not, as we'd say, we're not the only company. If you look in the battery industry and you look around the room, there are some tremendous amount of innovation going on. I think it's going to propel the battery technology forward. It's not Moore's Law. Okay, it's not all batteries, but in certain areas they're going to be great.
Right. Well, we'll hear from Altair Nanotechnologies tomorrow. But that's a good lead-in, I think, Keith, to what Nanodynamics is doing, and we're delighted to have you back this year.
Thanks.
I know you've been very busy.
A bit.
I guess the best thing to do is kind of just feed off of what Josh and Dave said, and kind of give us a view of, you know, nanotechnology and energy from your perspective.
Sure. Well, 2 years ago when Josh and you and I and Phil Koikis were here, nanotechnology was still kind of viewed as you say, kind of a broad, fundamental, general science that could do just about anything. And part of the issue, and I know that Josh has seen this, we have as well, is that the nanomaterials and the nanoscience really had not quite hooked up with a very strong market pull. Lots of possibilities from the microelectronics area to the biological sciences arena. Clearly, in the last couple of years, certainly the transition between 2 years ago and now, we've seen a very major emphasis on a couple of areas. Clean technology, which, again, I was interested to see that Lux came out last week with a report focusing on that. And, of course, energy. Oil being at the price levels that it's at and having gone through the spike, now all of a sudden people start to look at things that they might have considered to be perhaps a little bit higher risk, a little bit more at the end of the economic scale, where they weren't quite certain that the impact was going to be there, and now looking at it a little bit differently. The value proposition is now coming into play. You're starting to have people look at things from a system cost point of view, whether it's the Tesla Motors, vehicle, or the Phoenix SUV,
We'll
or
see
the
both
Black
of them
& Decker,
today.
right?
Yes.
The Black & Decker product. So what's happening is that we're starting to see, as a company that is structured around materials, and I say around materials because we're a technology developer, we're a materials manufacturer, but from the inception of the company, we've also been a product company. The first product that we made was intended to be what I call a mule, something to carry the materials into the marketplace. Even if it was ugly, even if people weren't all that excited about it, it demonstrated the capability of the nanotechnology, the nanomaterials piece. And for us, it was a fuel cell.
Are we going to get a demonstration of that today?
You're going to see that this afternoon in the breakout session.
Okay.
Actually running a small DVD player with, I hate to say it, but the video from the Buffalo Sabres playoff run, which ended last week for those of you who aren't sports fanatics.
Unfortunately.
But the fuel cell for us was kind of an interesting product because you looked at it as there were trends towards more portable power supply, batteries certainly being among them. But the opportunity to take a power generation device into the field, run it off conventional fuel, and achieve the kind of conversion efficiencies that fuel cells are capable of doing really was intriguing. And what we saw was that by taking nanomaterials and integrating those into the fabrication of these particular products, the power density, the power conversion, the fuel utilization, we saw figures of merit that had not been reported even in laboratory settings.
But you avoided the PEM-based technology, right?
We
You
avoided
steered clear of that.
We avoided PEM because for us the issue really boiled down to fuel. PEM systems operate off hydrogen. You heard about the issue with platinum as a catalyst. That relates primarily to the PEM-based systems. And although you can get hydrogen today from a conventional fuel, you have to throw away the carbon part of your hydrocarbon. So as a result, your fuel utilization is not there. And the infrastructure for hydrogen does not yet exist to really deliver it broadly or on a global scale. So we looked at a product that would run off a conventional cylinder of propane that you could go down to Kmart or Home Depot, pick up off the shelf, and literally plug into a fuel cell device that then could be used to run remote sensing equipment, oil field pumps, water sensors, and a number of different things. Of course, the military was interested in it. And over the last several years, what the military has kind of identified as the biggest opportunity for portable fuel cells is to recharge batteries. So now instead of a combat soldier hauling 30 pounds of batteries out into the field, he can haul 5 pounds, and when he gets to wherever he's going to encamp, they can take and plug the batteries that they don't need at that overnight into a battery charger that's providing power from a fuel cell.
Right.
So the combination becomes interesting. I think you'll see that on electric vehicles. You'll find fuel cells as a way to keep batteries charged using conventional fuel, including gasoline, diesel, and the like.
Right. Well, I was talking to somebody last night who works for a trucking manufacturer, builds these big diesel-based trucks, and a lot of the drivers park overnight and they let the trucks idle all night. And I thought, wow, here's a great application for a fuel cell power. I mean, these things are basically living rooms inside of them. They spend all night in them. They've got their computers and their GPSs. So could you take a portable fuel cell and power up a truck and, kind of solve that problem of having to idle all night?
Absolutely. We've spent the last 2 years working on a system that'll operate off even high sulfur diesel. So those systems exist. Since we've got a limited amount of time, though, the one thing that I would say is that 2 years ago we talked about the exciting part of nanotechnology being the fact that you could now create these designer materials and structures to attack a problem. The whole space, clean tech and energy, is clearly giving us a number of very identifiable problems that we want to go after, whether it's desalination or water filtration, whether it's portable power, what have you. And I really am excited about what's happening in the space in terms of how these materials are being adapted, integrated, designed into new systems. And I will say that it will surprise me greatly if in 5 years' time, the efficiency of, for example, photovoltaics aren't up into the range where they become a very, very broad source of power around the globe. We're seeing work down at Los Alamos in nano-sized semiconductor crystals that generate 7 electron hole pairs, 7 excitons, which gives you the potential of a thin film photovoltaic that has greater than the theoretical 100% conversion efficiency. Something like that just is a game changer in terms of energy on the planet.
Yeah. Well, I was at the Stanford University website. They have a global climate energy project that's going on for several years. Some of you may be familiar with it, but they have a technical report. You can go on and download it. Some of the topics: nanoengineering of hybrid carbon nanotube metal nanoclusters, composite materials for hydrogen storage. That's a mouthful. Engineered nanostructures for hydrogen storage, nanoengineering of hybrid carbon nanotube metal nanoclusters, hydrogen effects of climate, stratospheric ozone, air pollution. I mean, the amount of research today that's going on in the intersection. Mark talked about it last night in his run-up, in his presentation, or his remarks before Craig spoke, which I thought was just a mind-blowing presentation. But he talked about the convergence of all these technologies, and I think that's really the power of nanotechnology. Has always been a multidisciplinary affair, and it's bringing all researchers from all these different disciplines. I think biology is going to have a huge impact on the development and the intersection of biology and nanotechnology. I mean, biology is the study, really, of nanotechnology. I mean, it is a nanotechnology, right? We look at self-assembled organisms, species. I mean, really, that's where I think we're headed here. And we've tried to give you a taste this morning of, big picture of energy and nanotechnology, battery technology. I'd like to encourage all of you to join us at 4 o'clock. We're going to demonstrate the Nanodynamics fuel cell. We're going to let Dave let his hair down. We're going to have Josh go into more detail of what's happening in the venture capital community. We appreciate your time this morning. Thank you very much.
All right, thank you.
Okay, thank you. Thanks.